So we still need a note taker. I asked for volunteers earlier, and everyone avoided making eye contact. Um, if you're all right, Jonathan, thank you. I think you've pulled us out of the fire more than once, and I appreciate it. Thank you. Yes. Usual rules for note taking apply. Uh, you know, the main thing is to record decisions and things that uh, can't be easily extracted from the discussion. Um, we are the first session of the day. We are gonna probably wait a couple more minutes if people drag in. But this is the OpenPGP session. If you're here for something else, you should go somewhere else. Um, uh, Stephen Farrell and I are your co-chairs. Um, I will start going through. This is Thursday, so you've probably seen the note well, which describes the obligations and expectations of you if you're working within the IETF process. Is this? I have no monitor. I can't tell if this mic is picking up. Uh, Perhaps someone who's remote can tell me if they can hear me on the. I'm looking at the chat. Oh,
Yeah, it sounds good.
okay, great. And yeah, anybody else who is planning on presenting remotely, if you want to test your mic and your video right now, that's good. Andrew, we heard you just fine. So maybe Daniel or Falco.
Hello, test, test.
Great, we can hear you and see you.
Yeah, test from me also. Actually, Aaron will.
Great.
Hello. Yeah.
Sorry, maybe I got that wrong about who's presenting. Excellent. Okay. Let me remind you, if you're in person, you should be signed in to MeetEcho. If you're in person and you come to speak, please, if you want to speak, please speak at the microphone. Get in queue to speak. When you speak at the microphone, make sure the microphone is pointed at your mouth, not at your shoulder or some other part of your body. And if you're remote, please keep your audio and video off. And if you can use a headset, that would probably help us avoid feedback. Please also remember the code of conduct. We're here to have a productive discussion about the mechanisms involved, not to do personal attacks, and not to prove that you're more sophisticated and know more jargon than anyone else. If you don't understand something, please speak up. You're probably not the only one. And some of us who are native English speakers may speak fast, and I encourage you to slow down so people can understand. And we want the best solution for the network itself, not for any one particular vendor or user. We also have stickers with the formal logo, the badge of the OpenPGP protocol. If you would like a sticker, feel free to come up and get one at some point. I can hand them out afterwards as well. This is the agenda. If folks want to modify this, we can modify it. But first, we'll have Eustace present the test suite status, the status of the OpenPGP interoperability test suite. Then we'll have a talk on post-quantum cryptography in OpenPGP, which I believe will be Aaron presenting, Aaron Whistler. And then Andrew Gallagher will talk about the key replacement protocol, which these are all adopted drafts. The post-quantum cryptography key replacement and then the persistent symmetric keys also is an adopted draft. And that will be Daniel Howens. I probably pronounced that wrong. Sorry, Daniel. If we have time, I can give an update on the latest version of the stateless OpenPGP interface, which is what drives the interoperability test suite. And then if there's room, there's any other business. It should be a full session. Anyone have any adjustments they want to make to the agenda? I don't hear anything, so we are about at 5 minutes in. If you haven't draggled in yet, you'll come in partway through. So yeah, just a reminder, since the last session, The crypto refresh has been published as RFC 9580. This is now the formal OpenPGP standard. The old standards have been deprecated and obsoleted by this draft. And there are multiple active interoperable implementations that are in development. And soon we need some releases of those. But so this is great work. It's really nice to see that finally out the door. And it's also really great to see multiple different implementations demonstrating interoperability. And with that, I will move to the interop test suite status from Justus. And you can just say next slide and I'll next slide it.
All right. Hi, I'm Justus. I work on Sequoia PGP. Next slide, please. So I'll start with the great news first. I found a co-maintainer. It's Daniel Gaurens, and he contributed loads of new and exciting changes recently. He contributed new tests and new test vectors, which is awesome. And then there are amazing usability improvements, like nicer to have, like sticky headers for the tables, but also you can select which implementation you are interested in, which is nice to, focus on what you really want. And then you can actually, if a test fails, you can get reproducers and you can just copy and paste them into your terminal and see the failure locally and debug it, which is super nice. And you can inspect intermediate artifacts with the packet dumper. And then he contributed the post-quantum test artifacts from the draft, and also just in the work in progress implementations of the post-quantum draft. So if you want to see those, there's a link, and you can also find the slides, of course, and click on it. And the other draft is the persistent symmetric keys draft, and we also have the test vector from that document there. Next slide, please. I'm happy to report that implementation of RFC 9580 is progressing well. We have 2 implementations that have released versions implementing it. That is RPGP and OpenPGP.js. And then there is GOpenPGP, which is, I think, about to release with the support in. And then there are 2 implementations that have work in progress implementations, but need a bit more time. That is PG Painless. And the author tells me that they will probably get it done by March next year. And also our implementation needs a bit more time. I hope to get it done by the end of the year. Next slide, please.
Sorry, I just lost my next slide button.
That's all right. I'm also happy to report that we containerized the test suite and we went the coarse-grained way, meaning that we will just create one big image with all the implementations and the test suite in, and then we can run it. And it's easy to do. Everyone can do it. The steps are roughly this. You need a bit more magic to get the test results out. If you click on that link or just go to the README of the project, you will find detailed instructions on how to run the test suite yourself. Next slide, please. And that's a great step, I think, for the test suite, because it used to run only on my machine back home, and that was terrible. But now everyone can run it, and it runs in our CI environment, and it's published from there. And we have an alias test.sequoiapgp.org that redirects there. And I'm thinking of creating an alias test.openpgp.org to further empathize that this is not only a Sequoia project, but we think this is a great way for the community to come together and work together and improve all of the implementations. And that should be reflected in the name as well. And as always, I would like to invite you to join in the effort, contribute tests, contribute to the framework itself. If you have a PGP implementation, please implement SOP so that we can plug it into the test suite. And I want to also call out for help because I think having this test suite is a major thing for the community, and it took quite a bit of effort to build it and to maintain it. And I once heard that single vendor technologies fail. And I don't want this test suite to fail if, for example, our project should fold. So please come in, get familiar with it, so that if bad things happen, you're in a good position to help make it survive. And I also want to shout out to the SOP, which is a great spec, helps us inspect implementations using a black box method. And the new draft brings in interesting things like certificate updates and merging, which we want to test. So please implement that. Thanks.
Thanks. If folks have thoughts on this, or I don't see anyone in the queue at the moment. We have one question mark on the slide about whether it should move to test.openpgp.org. It seems like it's cross-vendor enough to do that at this point. We have 2 people actively contributing from different projects. So probably if you have an objection to that, it might be worth raising it on the mailing list. I'm told it's working. Maybe I need just to be closer to it. Okay, so thank you, Eustace.
All right, thanks.
So this is the post-quantum draft update. And Aaron, I believe, will be presenting.
Yeah, correct. Yeah, hi. This is yet another PQC draft update. Next slide. And we are going to present the changes to draft that we've been doing from 04 to 06. 04, 5, we published it before the IETF. 06 was published after the cutoff deadline, like 2 days ago, but it's just a test vector update. For each of those points, we're going to have some few more slides explaining what does it mean. We're going to start with the NIST standards, then go to why we chose the seed format for the secret keys. And then we mandated these 6 keys, like we discussed at the last IETF meeting, for encryption algorithms too. And then we, hopefully for the last time, reworked the CAM combiner. Next slide, please. So these are the new standards that were published in August from NIST, and they replaced the initial public drafts that we had, and they have been implemented in pretty much all the libraries that we're using. So we got them into everything but Go. This means we also managed to create test vectors for MLCAM and MLDSA, and they are in the draft. Next slide, please. Now, we chose the seed key format. So the new standard offered 2 different options, either the explicit format for the private keys or the seed format, where you just have 32 or 64 bytes, and you derive the key from that. And this has a few advantages for sure, the smaller keys. And well, some libraries do prefer or offer only the seed format. And then no matter what is in this data, it can never be invalid. You will always generate a valid key out of seed. And also to align with labs that also decided for the seed format, we like all of these on top of the discussion that happened on the list for the seed key format. Next slide. So the key derivation and combination, this is probably the major change that has happened. And what we have done is we had a provisional key combiner. We updated it, adapting it to NIST SP 800-108. This makes it already compliant with the FIPS standard, technically speaking, because MLCAM, that is already a NIST standard, is compliant and is in the first position. So effectively, you could consider it already as a derivation of MLCAM with additional information that is an elliptic curve, because anyway X25519 is not NIST approved at any point. And so we decided for this format that is already compliant with NIST, but on top of this, in a call that has happened approximately 3 weeks ago, NIST confirmed that this is also going to be compliant with the new construction. Next slide. Here is how it works. We have the MLKIM key share followed by the ECDH key share, and in the additional data, we pretty much put everything else. So the ciphertext, the public keys, the algorithm IDs. It's not optimizing for speed, it's not optimizing for the least amount of cycles, but it is robust and has everything in it. So it offers END-CCA2 security no matter which definition of it you use, and we favored a solid construction over an optimized construction in OpenPGP, where this is not going to make the difference whether the protocol is fast or slow. Next slide.
So just on our end, I see a few people nodding in the room. So it might be just, if you go back a slide, it might be just worth getting a few positive acts that people like this. I see Deirdre said that in the chat. But
okay.
Does anybody in the room want to say they like this?
Or that they don't?
Or if you don't. It would be useful to know if you do. Go to the mic.
Quinn Dang at NIST. I have some clarification question regarding to the construction here. So if when we derive keys from the MLCAM output, okay, then the construction KMAC is good and approved by NIST. But when you concatenate it with a non-NIST approved shared secrets, then if you put that, if you don't treat that a non-NIST approved shared secret, you put that in a different area from the key to the KMAC, then it would be a compliance. But if you put it along with the MLCAM share secret, then the whole key there for the KMAC is not NIST approved anymore. However, if you concatenate MLCAM and a share secret key, not share secret key from EC Diffie-Hellman from NIST option, then it would be approved, because we allowed multiple share secret keys, not share secret keys, which are generated from NIST approved methods, to be treated as a one key for the KMAC. But yeah. So it depends. So the ECDH key share keys, if it is from one of the NIST ECC options, then it will be okay from this perspective. But if it's coming from something not NIST approved, then treating both of them together as a key currently is not NIST approved.
So I have a kind of perhaps naive question for you, Quinn. I think I heard more or less this similar discussion in LAMPS yesterday. When are you guys going to just approve 25519? Because that would solve a lot of these things, right?
What I heard from my management is that we wanted to focus on updates to post-quantum and right now, and my management right now doesn't have a plan to do more testing with the curve 22519 in Diffie-Hellman, because we are focusing on post-quantum migration.
So just to note that I think both here and in LAMPS, the lack of blessing for 25519 is causing difficulties with post-quantum migration, because people have to think about all these things, right? I'm not asking you to solve it. Take it as some input.
Thank you, Steve. No, just give us input. I don't feel any offended at all. we welcome all inputs and suggestions from the community, and then we make a decision based on them, and we go from there. But I'm not a decision maker.
Totally.
Yeah. But thank you for that input. Yes. I will pass it along.
Great, thank you, and thanks for the clarification.
Yeah.
Quinn, if you can stay at the mic for a second, I would have a follow-up question.
Okay.
There's also the option, instead of using SP108, of using SP56C, if I recall correctly. That would mean that instead of using a KMAC with the key in here, in the first parameter, it uses the KMAC as a one-step derivation function, and puts the key actually concatenated with the rest of the rest of the additional data into the second argument of KMAC. So it would basically be the same that you see on this slide, just with a fixed information into the key and the MLChem key share and ECDH key share into the second, so after the comma, let's say.
Yeah, if you move the ECDH key share to a different, to like a part of the other inputs in that set, then it would not violate the KMAC KDF. Yeah, or you could use SHA 3 to 56, and then you're good to go.
But would it be then a NIST SP, like which, I mean, maybe we should bring this offline, have an email thread, and
okay.
Discuss exactly what construction, because we assume that this would have been NIST approved. And if this isn't, then we can slightly modify it in order to get there. I was too optimistic when saying the last change to the KDF combiner, maybe.
Yeah, we can work offline later and work together to get something that needs approved. Yeah.
Mm-hmm. Okay. Yeah.
Given of what we just heard of how extremely and utterly difficult it seems to be to make a NIST approved combiner, can we do this work only once, please, and just use the LAMS one? Like, I really do not see the benefit of having two not compatible combiners coming out of IETF that try to do the same thing. The LAMS one tries to be FIPS compliant and comply with NIST. They had the same discussions as you noted yesterday. I really would prefer to have this discussion only once and solve it, rather than having it several times in a row.
So we also tried to bring this discussion to the CFRG to create even more trouble than it used to be. So I would agree in principle on aligning onto a single combiner if this doesn't make everyone go nuts about it. So like said in very plain words, if OpenPGP and LAMS can agree on something that NIST rubber stamps and says this is good, I am very happy for that.
Yeah.
If we need to get everyone on board with it and start yet another huge discussion about CAM combiners, I am no longer on board with it.
My own opinion on this in like various strategic things is unfortunately that at this point in time, given how extremely impossible it seems to be to get a NIST approved combiner, is to push for pure ML Chem, pure ML DSA implementation so that people can already launch something. For ML Chem, maybe also pushing for X-Wing, just because that seems to be a bit more mature based on not being encumbered by trying to be FIPS compliant. Unfortunately, if you want FIPS compliancy, then X-Wing does not really help you there either. So like that has been basically my strategy because of these, like I really wished it was not this way, because I wish that we could just deploy hybrids and do this thing that seems to be more conservative. But given the impossibility of creating a FIPS compliant combiner, I'm really getting to the point where I'm like, okay, I'll just use pure. I really wished it wasn't so. It is really not good, not a good situation. But I don't think that we get helped by having the discussion in LAMPS and PGP separately, though, because as far as I can tell, LAMPS has the exact same goal as you do of creating a FIPS compliant combiner.
I see a comment in the chat about this from Daniel. The fact that the fallbacks for purely compliance reasons. I think I want to clarify your question whether it was use a combiner that focuses on the certification of MLChem only, but then still include the elliptic curve part as additional data. So make sure that the FIPS certification comes from MLChem. Is that the question? Is that your proposal, or is it your proposal to completely remove the elliptic curves?
That's not really a proposal for this draft, but like
Okay.
I'm getting to the point that I'm like putting my weight behind drafts that completely don't do hybrid at all, because there it's clear how to do it in a FIPS compliant manner. It is stupid, and it is not the most secure thing to do it this way, but it is the simplest thing to get through compliance regimens. And well, it wouldn't be the first time that compliance forces us to do something less secure than the literature proposes.
I know. Yeah, I know.
But yeah, like as far as I can tell, LAMPS tries to do the exact same thing as you do here of creating a FIPS compliant combiner. I don't know why it's such a long discussion. I really wished it wasn't.
Yeah, I mean, in this case, as far as I understood, would just mean move the ACDH key share after the comma. That would already be enough, and give a secure combiner as well as NIST compliant. So I would not move all the way to remove the elliptic curves, but if we can get there with a combiner,
So just
that would be great.
As a chair note, I think if somebody was to propose removing the elliptic curve and having a pure MLChem thing, I suspect we'd have to have that discussion with the working group as that discussion, not just as a addendum to the 100th email on combiners.
Yes.
Hi, yeah, so it's John Gray from Entrust. So yeah, I'm one of the authors on the composite chem draft and composite signatures and LAMPS. Obviously, we've had lots of discussions about this. One of the things we designed those algorithms to be like drop-in signature or chem. So like, all this stuff that you're doing would be taken care of at the crypto layer, and you could just, assign a new whatever algorithmoid or pointer, whatever you assign for OpenPGP for an algorithm. And then, we could agree, or hopefully we get to the point where we can get to, a chem combiner that's FIPS certified or FIPS certified, considered FIPS certified, but also for the composite. I know that's in your draft as well, because I looked at that as well. It's the same thing, right? We've been working on that for multiple years. We've had lots of discussions on non-separability properties. We have, those discussions have happened, and we think we hope we're getting closer to a final solution for that. So again, with that, you could also just define it as a signature algorithm itself, and just whatever code pointer or however.
Wait, that's what we're doing. So if you look at the alg ID at the end, that's a single algorithm ID for the combination of X25519 and MLChem.
Yeah, but I think you carry your keys separately, right? As separate components. Whereas at the other consideration is like crypto libraries, right? So if I implement my composite signatures in my crypto library, I want to be able to use the same thing for OpenPGP. Obviously, it has to fit into your scheme, but at the crypto layer, you just call the sign API and it should just work. And in fact, it would just work.
This what's on the screen right now.
Yeah,
we're talking about is not signatures.
Okay, we'll get to signatures.
Yeah.
I'll come up for that then. Sorry.
Paul, I think Paul is next.
Paul Vardas, AD, but not for this group. I do want to say that once this moves up the chain and gets to the ISG and also gets to me, I will definitely prefer that things get synchronized between working groups. And in fact, that's, I guess, as an area director, one of my roles is to make sure that each working group doesn't do their own thing, and then we have like a zillion RFCs with a zillion different things, right? And we'll talk about more of this at SAC on Friday, but it would be nice if you can reduce the number of RFCs needed for the same thing.
Yeah. No, I definitely agree with you. I will probably, I see that also Mike comment in the chat that he's available to align, and I guess the only thing we should discuss is how to get NIST compliantable CAM combiner that is that works for everyone. So it's LAMPS and OpenPGP do have similar conditions, like of synchronousness, asynchronousness rather, and performance. So I can't see why we couldn't do it, or also hardware that they run on.
Yeah. Queen Dang at NIST again. I have 2 points to share. The first one is with the X-Wing, the KDF in X-Wing. If it's ended, moving the constant from the front to the back, and still keeping the MLCAM shared secret key in the front, then that construction would be compliance with NIST in 56C, and that's easy to see. So that's another option for being chosen again, or for discussion. And the second point is that we specify KDFs in our standards, and then later on different standard bodies like us here, the IETF, decided to do something different. And then we have been working very supportively to update our standards and make exceptions to accommodate, to provide service to the community. And I think we've done a very good job at that. It's not that we did not, because KDF, you have 1,000 ways to do it. For a standard, you have to specify some good options in that, so then people have comparability and they know how to do testing. But it has been the case that sometimes we use different KDFs than from what we had specified. So that that's, and we've been supported, updated our standard to support the work here, because we know the work here is extremely important to the ecosystem.
Yeah, thank you. I'm not saying that the NIST standard is is broken or anything. I'm just saying that it is sometimes hard to understand. For instance, when you can put the counter at the beginning, we had this difficulty in the old version of the drafts and so on. So it's just a matter of parsing it correctly and making sure that what we're doing is actually NIST compliant. That's I guess is the hard part.
Yeah, so I would like to just say that I agree with Sophie that probably we really need both hybrid and pure versions of the algorithms, because like the other thing, that a big elephant in the room is the NIST certification queue. So if we do combining with P256 first and then MLCAM later, that will actually would be better, because then we can use the FIPS certified P256, and then like once we have the FIPS certified MLCAMs, then we can start use that, and maybe at that point we will be sure enough of the MLCAMs.
Note that this draft does not contain any curve that is for CAMs, any curve that is NIST certified at the moment. They have been split into a separate draft where they will do a similar thing, but is it's not the same. It's not the same, and therefore is and none of these algorithms will be able to skip this queue.
Mm-hmm. And the other thing is that I agree about like having just one standard for everything, both LAMPS and OpenPGP for CAM combiners and signatures.
Mm-hmm. Okay, thank you. Okay, as usual, the biggest discussion happens on the key derivation slide. Let's go on, please. Okay, now we have some good news instead. This is the implementation status. As you can see, except for Go, where we're stuck at the library with round 3 of SLH DSA, when it was still Sphinx Plus, everything else is already available at the library level, and we're just finishing to implement it up in OpenPGP.js. These are the libraries that ended up being in the scope of the project for now. Next slide, please. As Justus pointed out in the previous presentation, we do have interoperability testing. Daniel Huygens has been pushing this to the SOP and to the shared repo, and you can see that. I mean, you can go look at it yourself, and there are some very beautiful green check marks.
So Aaron, just for the benefit of the people in the room, they can't see the blocks in the left-hand chart. So if you can tell them roughly what the percentages are, because they're not visible on this particular screen.
It's like 100% for OpenPGP and OpenPGP.js, and like 75 for RMP. But honestly, I mean, we're just testing MLChem and MLDSA, so we don't have yet interoperability onto SLH DSA, so we're not testing that one. And these numbers are as of 2 weeks ago and changing rapidly. So please don't take what's in on this slide as set in stone. This is a very evolving result. Next slide, please. Yeah, so that's what we're testing. So these four procedures with MLChem and MLDSA. And yeah, Daniel, thank you, Daniel, for pushing this upstream. Next slide. So this is something we're proud of. We managed to close all the pull requests and open issues, and not because this morning I went there and clicked and closed on all of them, but because we've actually tackled the issues, we replied, we waited for people to have their complaints solved, or we declared them out of scope, but as well as after considering all of them, as well as the pull requests. As of now, there's nothing, no upcoming change planned. We will need to open up an issue right now with the CAM combiner after this meeting. But apart from this, I think we are fairly good en route. Next slide. So the next steps that we do have already is for sure the SLH DSA interoperability. So I do not know whether we're going to do test vectors because they're really huge. So including a test vector into the draft will just double the size of the draft from 80 to like 160 pages just of binary data. I don't think that's probably what we want. But what we can do is we can maybe point to where the test vectors are or add them into the interop test suite. It's just a matter of formatting. And also, in order to do SLH DSA test vectors, we need to assign some code points to them. I'll stop here and let Mike say something, and then I'll come back to the remaining 2 points.
Hello, Mike Elmsworth. Yeah, for test vectors, I have another draft in a RATS working group that has like extremely long list of test vectors, and that one actually we expect to grow over time. So just to disseminate, I chatted with the tools team. The problem is once that thing becomes RFC, you can't add more GitHub links in Data Tracker. That becomes like completely locked. And so the tools team suggested actually you should just point to a GitHub, like putting an informative reference to a GitHub, and then you can keep jamming more test vectors into your GitHub is a approach that's acceptable to the tools team, if that's what you want to do here.
I would still keep a few basic test vectors into draft where we have also the kind of all the intermediate steps and everything explained. And then maybe we could do a repo with the larger test vectors, such as SLH DSA that are really into the tens of kilobytes size. Daniel?
This is Daniel. I agree with the both and approach. There's no reason you can't link to some external repository, but we definitely want a test vector for each algorithm that's being specified, even if it's big, in the draft, because the external stuff can go away. And if you can get to this draft, you should be able to get to the test vector. So please don't let the size of the draft scare you, as long as you have a test vector for each mechanism in it. It really, if there's a problem with the test vector being too big, that's a problem for the tools team to solve and not for you to solve.
Okay, I mean, I'm talking about like 90% of the draft being a test vector.
That's okay. If the artifact is big, put it there. People don't have to read that by hand. They just need to be able to extract it from the draft.
Okay, yes, I hope no one will check it by hand. Okay, then I'll take this feedback and I will probably then add a test vector for at least one for each algorithm, plus a link to a repository or something where we can dump more information in case needed. Now, in order to do test vectors for SLHDSA, we don't have at the moment code points, and the question is whether we want, as a working group, assign actual code points to all the various algorithms. I think that once the standard is stable enough, we should start with using dropping test code points we have right now and assigning 40, 41, and so on.
So just a question on that, Aaron. So I guess if we had some discussion about combiners, so presumably that would need to be resolved before we want to allocate code points. For the SLHDSA ones, is there any reason other than just waiting for the implementations to mature? There's no specification reason why we couldn't allocate code points for those whenever we want. Is that correct?
I mean, also for MLDSA, that is like.
Pardon me. Sorry.
The signatures, yeah.
Yeah. So, yeah. So essentially, the signature ones we could go ahead with as soon as we're happy with the implementation. There's no specification holdup. Whereas with the chem combiners, we probably want to get that nailed down before we allocate code points. Does that sound right? Mm-hmm. Okay.
Yeah, I know composite signatures is in this draft as well. So what about that? So, I mean, I think if we can align on one, then we should.
So we do have
I
composite
suggested
signatures.
in the chat, like look at, the composite signatures and lamps, for instance. And then
exactly, like the thing is, we do have a different setting than lamps. We do not have non-separability issues. These are as signatures as if they were a single algorithm. There is no way to use a part of it somehow.
But if you use it,
and
yeah, I was gonna say if you use it just as a signature algorithm, and okay, maybe you don't need that property for whatever reason, but if it's there, that's not terrible, right?
I mean, but it's already there. We don't need anything else. We already have it. We already have non-separability. If you take one of the two components and you try to do anything with it, it's going to result in an invalid signature.
Yeah, it's just, so me as a software developer, so I implement, this one and it's used in different places, and then I want to use OpenPGP, so now I have to implement this, this extra new one that you guys are doing. And then I'm probably going to make mistakes along the way and stuff isn't going to work. And why don't we just use one?
Because it's literally our signature algorithm is take A, verify signature A, take B, verify signature. They are in the same packet, and then literally do AND in if A and B. That's it.
And lamps too. We verify. You sign both, and when you verify both, and it's AND as well.
And basically what?
Yeah, I mean, if there's an important distinction, sure.
the distinction that in the lamps group is not in the is what they sign is actually not the message itself, but the Scott system. What they signed is not the message itself, but a hash of the message along with some other stuff.
Depending on which mode you're using, pure or hash. But anyway, we should probably just talk and see if there's a way that we can align or something. Just because.
Okay, I think that FICO might have some comments here.
Okay.
Yeah, I can only reinforce what Aaron said. So there is no actual problem to solve in OpenPGP. There is no complexity introduced, no significant complexity introduced by just verifying two signatures. The complexity and dependencies that you introduce if you want to align with other constructions and require now to call a library just to verify two signatures, two parallel signatures, that's not justified at all. And then you have much more much more complex construction. You hope that you find it in the library, but if you don't, you have to implement it for no reason. So I think this is requiring too much. And we should remember that these protocols, they have never tried to align before on such a level. So this is quite quite a new idea that the working groups have to align on all their constructions, which just doesn't seem to be fitting. Also, this would mean to introduce OIDs into OpenPGP, which is not natural because OpenPGP does not naturally use OIDs. It has its own.
Wouldn't it just be a code point for you? Just like
so then the library that you
point, and then the crypto layer is doing all the work. As long as the crypto library supports it, it's doing the work, and you don't have to change the protocol. Or, do one and then the other within OpenPGP. You just do it. You just do it at the crypto layer. That's it.
I don't see any advantage from this. So you have another requirement for the crypto library that it can handle OIDs and OpenPGP code points.
But it will, because your crypto libraries, I guess you're saying if it doesn't have it, then yes, I can see your point. But if a lot of crypto libraries have it, why wouldn't you just use it?
They have it? What do you mean? They have it already?
So if composite signatures is implemented in my crypto library, you can just use a code point to reference that, right? And make use of that. Versus now in OpenPGP, you're going to have to implementation, extra extension, this thing that goes out to one and goes out to the other and does all that work. When you can have the crypto library already taking care of it for you.
Yeah, you have three lines of code.
That's
verify
just what
A, verify B, and then check that A and B are true. The results of A and B are true. So there's this 3 lines of code for which we're trying to make an alignment between two working groups. I think this is quite unprecedented. So this is something we should keep in mind. We have many things.
I agree.
Between CMS and OpenPGP. So why are we trying to align on this small detail with such a such
I
determination?
agree. It's not really complicated. It's like you said, a few
I
lines
can
of
point
code.
out
It's a for loop,
many
basically,
problems in the AAID, or there are some problems in the AAID of CMS which are probably much more severe. And no one has ever made any attempt to align OpenPGP and CMS AAID, even though there are actual problems. So, and this is just about 3 lines of code. I don't see this is in relation, I must say.
So I guess people have made their points, and
okay.
Thanks for letting me make the point. Anyway,
Queen Dang again. I'm not representing an opinion here. I just wanted to point out the fact that in this document, we don't use any prehashed versions of the signatures, right? Yeah.
No.
Okay.
The reason is that libraries simply don't offer an interface for that.
Yeah, understood. I just want to make sure the whole working group is aware of that and be happy about it, because we want this document to be perfect.
Yeah, I think we had this discussion on the list. It's not actually, didn't mention it on the slides, but there was an extensive discussion about pre-hashing versus non-pre-hash on the list. And the reason why in the end we decided to go for the pure version is because we do already hash something that contains all the hash information. So what we are hashing is never a pure message, and therefore we do not have cross-hash attacks within the protocol. When it comes to using the same signature with another protocol, such as CMS, this becomes a little bit out of scope. In the draft, we recommend not to reuse the same keys across protocols. Simply just generate fresh keys for two different users, two different protocols.
Hi, I think I'm up. I made this comment in the chat. I think the composite chems in this draft are fine. They might be even a little bit overkill for the properties that MLChem has, but I don't know enough about OpenPGP as a protocol to say whether including the public key and ciphertext in the combiner is overkill or just right for, identity binding properties or whatever protocol level properties you might want. It's nice and secure, and I like it in general. For the composite chems, and to back to whether using KMAC and which key material needs to go where, like maybe you can figure that out, how to make that doable in the FIPS compliant way. But over with Xwing, we use SHA-3, which is FIPS compliant, and it does let you do the concatenate everything together as the pre-image to SHA-3 as a secure KDF. And that is FIPS compliant. You probably don't want to change it now, but that is an alternative option if you need to consider it. For composite signatures and trying to vaguely align with lamps, I am coming to the opinion very strongly that composite signatures are a very different beast, and they're much harder to do in a reliable or very secure way versus composite chems. And I might even suggest splitting this document into the composite chems part, which we think we can do pretty well, and maybe a composite signatures part. But I would strongly endorse a separate document that's just pure MLDSA signatures, because I think those are easier to do. You don't have to align with anyone in LAMPS or any other working group. And depending on the lifetime of your signing keys, that might be plenty fine to do in practice, depending on your security posture. Thanks.
I think this discussion has already been held 2 IETFs ago, I think at 119, if I recall correctly, where we fought to death about the composite signatures and so on. And I think that also our chair, Stephen, should have gotten 2 beers for allowing this to happen. No, I mean, seriously, the thing is, we decided not to split because our idea is the fact that we want a single standard that says this is how you can do OpenPGP post-quantum, and not having to repeat ourselves into separate substandards. Nothing prevents us from doing signatures that are standalone MLDSA, into a separate document. So if in 2 years we need a document that does this, we can easily do it. And I would say that at the moment, this is the compromise we already reached, and I would prefer not rediscussing it again.
Thanks. Let's move along because we are almost halfway into our meeting and we have 2 other substantial.
Yeah. Well, this was the last slide. So, like you, DKG, yeah. Can you go back a second to the previous slide? My question is basically, how should we proceed with code points? What's missing to go for last call? At this point, for sure, after this discussion we had, I would say that the CAM combiner is still a hot topic. I will personally sync up with Mike, also with the other authors and so on, and try to try to sort it out to get a single combiner that is FIPS compliant based on 2ML CAM being FIPS compliant, because we cannot use anything else to be FIPS compliant in this draft. I will take care of the GitHub test vectors, so a repo where we can put additional test vectors on top of the ones that are already in the draft, and add one test vector per algorithm in the draft, as suggested by DKG. And the question is whether we should start assigning code points, at least for the signature algorithms, and then once we sort it out on the list, the CAM combiner also for the how it's called, also for the CAM algorithms.
All right. Thank you, Aaron.
Thank you.
That sounds like the right outcome from today's discussion.
So I just don't recall right now for these code points. Does anybody remember the IANA registration rules for them? Specification required, or?
It's expert review with the latest RC.
Okay.
But I think in our case, it would be enough. I mean, we're trying to do an RFC, so I guess.
Yeah. So basically, the as a working group, the chairs can ask for a preliminary assignment anyway. So, or provisional or temporary or something. I can't remember what it is. So we can get those done perhaps more quickly than. We don't have to wait until the document becomes, is in the RC editor queue to get the code point.
Okay.
Quinn Dang, is this okay if we use the OIDs that NIST specified? Is that a code points or no?
There's no OIDs in this column.
Yeah.
Object identifiers are outside the room. There are none of them in this room.
Yeah, I mean, like basically just identify something unique within the protocol, and our OID is more than that.
OpenPGP uses single octet identifiers here.
Okay.
Okay, thank you very much. And well, that was a really productive session.
Thanks very much, Aaron. Page 1 of 19. Yeah, I'm going to apologize in advance for the number of slides here, but I will try and get through them very, very quickly. The reason that I wrote so many slides was because I wasn't sure I was going to be able to present today, and so I tried to put as many of my own opinions in here, so that somebody else could relay my opinions to the group if I wasn't able to present. But I'm here now, so I should be able to rattle through these pretty quickly. Next slide, please. So this is just a recap of the basic design. I'm not going to dwell on this. We've spoken about this before. Just this, we are designing a new signature subpacket for use in revocations and self-signatures. And I'll go through the rest of it as we go on. Next slide, please. So changes since the last interim meeting. So the first thing that we did was we removed the subpacket version field because that was not necessary. The target records that refer to the replacement key or the original, they now have a length field so that we can handle unknown fingerprints. So we can parse over target records of an unknown length. And we have added a little bit of explicit guidance for encryption subkey selection. It is not comprehensive because there is disagreement over between different implementations over how to select subkeys to encrypt to. But we've added, I hope, sufficient additional guidance just to make this particular draft unambiguous. We also bike shedded a bit of terminology and some draft names, and again, we didn't reach a solution that made everybody happy, but I think the current status is clear. It may not be to everybody's taste, but I hope it is clear. The name has been changed. It is now closer to Daphne's original draft name. I changed it before, and I have now partially rolled back the draft name. Next slide, please. So we have three major outstanding questions that we really need to get done. There are a couple of slightly less necessary ones that we can tinker with, but in order to get implementations up and running, we definitely need at least these first two decided. So next slide, please. The big one is the target record format. So the idea behind the topology of the references, we basically have a directed graph of references between keys. And what we wanted as part of the design brief was that we would be able to traverse this graph in multiple directions, so that we could potentially try to upgrade to a new key, and then if we don't support the encryption algorithm on that new key, we could fall back to a preferred older key, so that there is always a single preferred key, and then there is an ordered list of fallbacks that we can go down to. So the way that we do this is through a many-to-one mapping. So we have many fallback keys, and they all point to the one preferred key, and then the one preferred key has a one-to-many mapping where it lists all of the fallback keys in order of preference. This fallback mapping potentially would use references to v4 keys, which use SHA-1 signatures. And so there was a potential question about the strength of the SHA-1 hash algorithm and how cryptographically secure that is. Now, as Justus has pointed out, this requires a second pre-image attack to be exploitable, which we believe is still highly unlikely. But what we have done as a belt and braces, possibly overkill solution, is we have added an imprint field, which is essentially the same thing as a fingerprint, but it is made using a stronger hash algorithm. And that means that all of our cryptographic strength is the same no matter which direction we point in, no matter which key we are referring to. There's a standard cryptographic strength. This was borrowed from the attested certification subpacket design, so it's not a new idea in OpenPGP. One question is, this could potentially result in basically a duplication of information. So if we're using a SHA-256 imprint and a SHA-256 fingerprint, we're including the same data twice in the subpacket. Should we deduplicate these if they are the same? That was one of the open questions. So next slide, please. Yeah, it's important. So it's important to remember that the imprint only exists to cover the gap in cryptographic security where we think there is a second pre-image attack against SHA-1, but not against SHA-256, which is, unlikely. We're not really sure. The fingerprint is included so that we can always look up the key. So if we are referring to a replacement key, we need to be able to obtain it somehow if we do not already have it. There are various methods for obtaining and distributing keys. Some of them require fingerprints to be available, and that is why the fingerprint is currently always included. The cryptographic strength is equal to the imprint, not the fingerprint. So even if the fingerprint uses a weaker hash algorithm, the overall strength is that of the stronger hash algorithm because they're both always included. And of course, when SHA-1 will die with v4 keys, because v4 fingerprints are the only place where SHA-1 is still used every day in OpenPGP. So the goal now is to find the correct balance. Next slide, please. So the current state is that we do not deduplicate. We always include both the imprint and the fingerprint, even if they are the same. The fingerprint we use to look up the target key, the target certificate, and the imprint we use to verify it with the correct cryptographic security. We are talking here about 32 octets on the wire. This is pretty much nothing when we're talking about, for potentially tens of kilobytes of signing keys. And the parser is really, really simple. There are two fields, well, three. There are three fields. There are always three fields. You parse them. That's it. Done. And this is still my preferred, personally, my preferred solution. But at the last meeting, we were asked to look into alternatives. So I'm going to provide some alternatives now, just for completeness. So next slide, please. So the option 2 is what I would call opportunistic deduplication, and this is pretty simple. We still have the fingerprint. We also have the imprint, but if they are the same, we omit the imprint. And because we have a target record length now for more robust parsing, we can always know whether the imprint is there or not by the length of the record. So it's slightly more complex parser. It saves a little bit of space on the wire, and we don't actually lose any information. All information is kept. Next slide, please. Option 3 is what I would call a lossy deduplication. So the imprint is always used for the cryptographic security, but the fingerprint is optional. And the motivation for this is that there may be use cases where the fingerprint is not required, and it would be nice to be able to say that we are not reliant on SHA-1, that we can write an implementation, that does not use SHA-1 at all, and it is still compliant with the OpenPGP standard, and also always uses SHA-256 or better for all of its cryptographic functions. The downside of this is that we do optionally get rid of fingerprints, and we don't have a robust replacement for that. So we could, like if we are distributing certificates by other means like WKD or AutoCrypt, we might be able to ship all of the certificates together in a bundle with each other, and then you don't need the fingerprint to go out and look for them because it's already provided. But those aren't universal systems. Not everybody uses WKD, not everybody can use AutoCrypt, and the alternative would be rebuilding the key server network to allow lookups by imprint, which is a significant investment of time and effort, which we currently don't have because the key server operators were all basically doing this as a side, basically voluntarily. We're not getting paid to run key servers currently. So there's a question of, is it worth the effort, and is somebody going to fund us doing it? Next slide, please. We also have to say that this option is still on the table. To go back to the previous version of the draft where we just use the fingerprint, and if SHA-1 isn't good enough, we suck that up, because it's only ever going to be used if we are referring to a v4 key. And again, v4 keys are the previous version, and with any luck they will slowly die out and get removed from the ecosystem, and maybe that's fine. Maybe we do want to just use the SHA-1 fingerprints, and is that good enough? Again, remembering that it requires a second pre-image attack, so the exploitability is low. Thanks. Next slide. So I'm going to throw a spanner in the works here very quickly. Next slide, please. Currently, there is a line in the draft, and this goes way back, which says that a preferred key server subpacket may be included to recommend a location to fetch the replacement certificate. Now, it does say that the preferred key server subpacket is already used to mean the place where you find an update to the current certificate. If we overload this to mean this is where you get the current certificate and potentially a long list of alternative certificates, we constrain its usefulness because they can't refer to multiple different places. They all have to be on the same key server, which limits its usability. Ideally, we would set that independently for the current key and every target. Alternatively, we could simply remove this section entirely. We don't mention the preferred key server subpacket at all. There are concerns about the preferred key server subpacket and whether we should be using it for anything, considering that it could be used as a web tracking bug. Potentially, you ship somebody a certificate and they automatically refresh it from an attacker-controlled location. So maybe we don't want it at all. So next slide, please. So either we remove the references completely to the preferred key server subpacket, or we should lean into it and put the preferred key server information into each target record, which changes the wire format again of the target records. This removes all of the constraints, but at the expense of making the parser even more complicated. So next slide, please. So we need to make a decision on the wire format on the target record format. And I personally would like to keep it as simple as possible. And I would plead to everybody not to get rid of fingerprints, because it is one of OpenPGP's strengths. I believe that every key, every certificate has a unique identifier. We know from the history of OpenSSH that having multiple different identifiers for the same thing can make things complicated for end users, administrators, power users. I'm personally very reluctant to go down that road. And again, SHA-1 is on its way out, and 32 octets in the wire is nothing. And if we do decide to put a preferred key server field into the target record, we will need a fingerprint. But we need to make a decision fairly soon on this, because we need to let the implementations, we need to start work on this, and this is basically holding up the implementation. So I will take a break for a second here, and if anybody wants to jump in with an opinion on anything, please do. Daniel.
Yes, thanks. I will repeat my opinion from the mailing list, which is that in my mind, the main use case of this draft is to switch from a v4 to a v6 key, right? So then you're including a v6 fingerprint, which is already a SHA-256 hash. So I don't think that including the imprint is critical. But then again, I also don't think it's a large implementation burden. So I'm fine with either keeping it or dropping it. Yeah, both are fine to me.
Thank you.
Do you have an opinion on the PKS?
I'm not sure it's that useful, to be honest, mostly because when you're at the point where you're switching to a key, to a new key, it's a bit late to include something in the old key, right? So for it to be useful in my mind, you have to include the preferred key server in the old key when you generate it, and then sort of commit to also putting the new key there on the same key server, at which point, like, I think it's simpler to just say, the recipient can find the new key wherever they found the old key, right? Yeah, that's the only real thing they can do anyway. If you're switching to a new key and you want to switch to a new key server at the same time, you would have to like update the key on the old key server to say, well, I'm going to use a new key server now. I mean, yeah, I guess it's possible, but I'm not sure it's really needed or all that useful, but
yeah, it does get very complex when you start considering all of the combinations. And again, if preferred key server subpackets aren't used that much in by implementations at the moment, should we overcomplicate this by bringing preferred key server into it at all? That's my question.
So I don't see anyone else in the queue. I'm going to start with a question on the preferred key server, which just says, are you okay with dropping the reference to the preferred key server from this draft? After that, I'll run a poll that says, would you support, are you okay with putting the preferred key server information into the record format? So first one is open now. So going to leave folks with a little bit more time. A fair number of people have no opinion, which is perfectly fine. I'm going to switch to the next prompt shortly. So now's your chance. Okay. So new one. How do I do this? Generate show of hands.
So that was 7 people were okay with dropping it, so 6 no opinions, and 0 people didn't want to drop it. We're not okay with that.
So this question is, are you okay with including it in the record format for this key replacement subpacket? And people are vigorously holding no opinion.
They strongly have no opinion.
Okay.
Okay. Yeah, so I will take from that it's fine to drop references to the preferred key server subpacket, and I'm going to choose that based on the fact that nobody has an objection to it, and it simplifies the draft and it simplifies implementations. I think that's the way that we should lean. So,
okay, and then just for the audio record, there was 3. The second poll had 3 yes with including, 3 no with including, and 12 firm no opinions.
So do we want to do a poll on this fingerprint versus imprint question? This is challenging because, Andrew, you've managed to parse it out so finely that we have something like 6.5 options.
At the moment there are 4 options. There's options 0 to 3. So option 1 is no change, current is fine. Option 0 is go back to the previous one, to the previous draft, which did before we mentioned imprints at all. And then options 2 and 3. 2 is we deduplicate when they are the same, but otherwise we leave things as they are currently. And then 3 is the aggressive change where we can optionally just not include a fingerprint at all at will, which is the one that I would strongly urge people don't choose.
So option 1 is your preferred option, right?
The current is my preferred option, yes. Option 1, yeah.
Quinn, do you want to?
Hi, I'm Quinn Deng. From the poll, so I have maybe it's good that to give people time to think about all these ideas and all the issues, and then we would have a poll or something later, because there are a lot of non-opinions. That means people are not sure they truly understood what was going on.
That's true. If you've read the draft, you would know what was going on. So,
Yeah,
we can really only take input from people who have read the draft, I think.
Just give people a little more time.
Yeah, I mean, these are not fully fixed decisions, right? As of right now, I mean, we don't make decisions in the meeting. This is just to give feedback to the document editor.
Understood.
Yeah. But I mean, you do have to read the draft and give feedback if you have a concern with where it's going. And so far, the only recommendations that we've given have been to simplify it by removing the preferred key server information. And if you think about it and you think that's a problem, then please speak up on the list.
Yeah.
So Andrew, I'm just going to ask this poll as with a single question, which is just, do you object to option 1, keep the fingerprint and imprint, no deduplication?
Yeah,
is that
please.
Okay.
Yeah.
Aaron, you want to jump in?
Yeah, and I just want to say that I think option 0 and option 2 are wildly different. So it's like saying, do you like option 1 or not? It implies like if it comes out to be not, it's a problem, let's say, between those. Or do you want them to do another poll?
We'll have another poll afterwards. Yeah.
Okay.
So the current poll is, do you object to option 1, which says keep the fingerprint and imprint, no deduplication? So I'll give folks a little bit more time. If you haven't thought these through yet and you're in the no opinion camp, I strongly recommend that you read the draft. Aaron, you're back in the queue.
Yeah, so I voted no opinion, and I want to give a brief justification also for what I just mentioned, is that I think that, like, I am in favor of having a fingerprint, whether it's option 0, 1, or 2, they're all fine-ish for me. But the thing is, if I had to choose, I would probably also consider option 0 as valid. So.
Sure. We're not asking right now whether you object to option 0. We're asking if you object to option 1. And
yeah, but it's like, no, I don't object to it. It's
okay,
more
well,
like
that's good to know, right? I mean, these other options were on the table because people were concerned that the current status quo would be objectionable because of the potential for duplication. So if you have a strong opinion, if you find yourself with a strong opinion that you prefer something else, then I mean, I'm going to close the poll now. It looks like we're not seeing anybody objecting. And I think if you have a strong opinion for that you think one of the other options, should I ask one more question? Is there another option that you strongly prefer over option 1? Or should we just encourage, I mean, we have to take this to the list anyway. And I think if you find yourself with a strong preference for something over option 1, but not strong enough that you object to option 1, maybe try to formulate that in a message to the list. So for the record, the answer was 7 people said, no, I do not object. 7 people said, I have no opinion. And 0 people said, yes, I object. So Andrew, is that useful information for you going forward?
No, that is useful information, because like the impression that I did get was that we did have a large number of opinions about what people would prefer and what their preferred option was. And if we ask, because the last time around we asked people what their preferred option was, and we got, a whole plethora of different options. But my suspicion, which has been confirmed, is that yes, people have a lot of preferences, but they're not particularly wedded to those preferences. Yes, some people would prefer to go back to option 0. Some people would prefer to go in the other direction. But option 1, which is where it is not objectionable, or it's not strongly objectionable to very many people. So I think that is useful. I think it does demonstrate that option 1 kind of is somewhere close to the balance that would be acceptable to everybody, I hope.
Okay. I think we should
on the list.
Yeah, discussions on the list for sure. Let's move on.
Yes, please, let's move on. Next slide.
Justus, did you want to?
Just, are you in the queue for this or previous one?
Please finish quickly, but I want to say something and, be quick.
Sure.
You be quick.
So you want Andrew to go ahead and then comment?
Yes.
Okay, great. That wasn't clear. So Andrew, go ahead.
Okay, sure. So about the UX guidance is the other thing. So we did have a quick discussion on the list since I put this slide deck together. But this is just what we discussed before, which was how to create the bidirectional signatures, because we need a signature going in both directions. Do we have to have both primary keys online simultaneously to create these, or do we allow people to create one signature first and then the other one at a later date? So if we next slide, please. So what I proposed to the list, and which got a bit of feedback already, was that this is a general guideline for how we should proceed, which is that when we create or revoke a key, or if we trigger an expert option, because that always has to be available, we ask whether this is a replacement or original key for the other one. If so, we add the subpacket. And then when the other primary key comes online and we see that there is an unpaired signature, we ask, should we create the other pair in order to create the bidirectional signature? Now, it has been pointed out in the list that we don't always want to interactively ask the user for these things, and that's fair enough. So what I will do is I will loosen the guidance so to better take account of a fully automated process. But I think the general thrust of this, I think, is still valid. Justus?
So I raised the point online, but it was I felt like I was shut down. I strongly object to the name of the draft. It says the replacement key, but if I replace my key, that's, from my perspective, that's right. But for all of you, I have replaced my certificate. And I think, quoting Spock, the needs of the many outweigh the needs of the few, or the one. So it should be replacement certificate. I have more protein-rich feedback that I will take online.
Okay.
It's the title.
Okay. Well, will we take this to the list then? Okay. Well, does anybody else have a strong opinion on what Justus has just raised?
With no hats on, this is DKG. I agree that we should be thinking about the full workflow, and the full workflow involves the peer fetching the certificate and understanding the certificates and knowing that the replacement has taken place. The fact that there are keys being updated seems like a small part of the bigger ecosystem question that this is trying to solve. So I do lean towards thinking about this as a certificate replacement. But what I want fairly clear guidance for how to consume it, not about how to create it is small compared to thinking about how to consume it.
Okay. There is guidance for how to consume it already in the draft. It may not be comprehensive enough. So if there's any improvements to be made to that, please suggest them. there's only a couple of there are two worked through examples of how to consume the subpacket, but there may be other examples, obviously, that haven't been covered. So I don't have any slides for that at the moment, but we could probably take it to the list. Okay. Well, in that case, next slide, please. So we have a couple of minor outstanding questions then as well, which is the current guidance about the selection of encryption subkeys sufficient? I realize it isn't currently comprehensive, but when we tried to when we opened that discussion, it was clear there were a lot of conflicting opinions, which I wasn't sure belonged in this draft and maybe should be pushed out to a later date. The second option there is just do I need to change the record length field to 2 octets for just for future proofing? The preferred key server subpacket actually doesn't apply anymore because I think we've decided not to include that. But there are cases whereby if we had a version 7 key at some point in the future that used a longer hash algorithm for its fingerprint, and we had signatures that use a longer hash algorithm, we may get the record field might overflow 255 octets. So it might be safer to put in a 2 octet record length field just to be on the safe side for future proofing. And then there's, as has been already raised, is the terminology used in the draft currently clear? Eustace suggests maybe it's not. So maybe that's a discussion that we still need to have on the list. But next slide, please. This is probably a horribly optimistic timeline, but I would like to get a new draft out, in November with the major outstanding questions addressed. So if you do have an opinion on anything that has been discussed already, please take it to the list if you have not already said it, and let's nail this down. Let's nail the wire format down at least, so that then we can start worrying about cleanup and language and finalizing the bits and pieces of the document, rather than worrying anymore about the design or the construction. And hopefully early next year, we'd be able to get some implementations for testing. Thanks very much. There's just one more slide which has the references on it. That is me. Thank you.
Thank you, Andrew. I hope this was useful in giving you some feedback. And
It has been.
Great. And the rest of the working group, please take concerns that this may have raised for you to the list. Daniel, I think you are up.
Yes, thank you. Can I request control of the slides or no?
Yeah, I don't know how to agree to that.
Go up here. There you go.
Yes, thank you. Yes, so for those not aware, this draft is about storing persistent symmetric keys that can be used to encrypt and authenticate messages symmetrically. In my mind, this is kind of a companion draft almost to the PQC work, in the sense that given that it's much more expensive to encrypt and sign things asymmetrically, using PQC, you might want to, store things symmetrically protected for archival and so on. So yeah, a short status update about the draft. So I updated all the references to point to RFC 9580 instead of 4880. This is all of this is only on GitHub for now, so it's not yet in the data tracker, but I will mint a new version of the draft sometime soon. Then, as we discussed at the last IETF, I reserved some space for future and also for private or experimental symmetric algorithms. And then I added some test vectors, both v4 and v6 keys, and also messages signed and encrypted using those. And so here's the current status of the table in the draft. Still, AAD and HMAC are still there. The changes also, again, that were discussed at the last IETF, have been applied. And as I said, new reserved code points. I went with 200 to 210 for the private or experimental ones. I think the symmetry only makes sense in decimal, but I don't know. If anyone has strong opinions about these code points, let me know. So yeah. Then for the implementation status, I updated both OpenPGP.js and OpenPGP to implement the changes from the last meeting, and also added test cases to the interrupt test suite, as Justus mentioned. And so those are green now. So we have passing test cases. This first table is about v4, and the second table is about v6. So yeah, obviously still only 2 implementations for now, but hopefully this should sort of make it easier for other implementations to implement it as well, if they wish. Yes, go ahead.
This is Daniel. I'm asking from the floor, not as a chair. Trying to understand how this works given SOP's constraint.
Right.
I know that the test is based on SOP. Can you talk on that?
Yeah, I do have a slide about that later on, so I will get to that. But it's true that technically speaking, this is a hack. But first, I'll get to some open questions, or really only one, about the wire format. Even though we did discuss it at the last IETF, but there was no, very clear opinions at that time. But so yeah, just to remind, I changed the PKSK format for AAD, so the first row, rightmost column, to only have the IV and ciphertext, and there's no length octet anymore. And also the AAD algorithm was moved to the public key format from the PKSK. And this means that when you're parsing the PKSK by itself, like without access to the public key packet, you don't necessarily know how long the IV is, so you can't separate the IV and ciphertext. This is something that I noticed while implementing the changes. I don't think it's sort of a huge deal, but I wanted to sort of bring it up. If I'm channeling Justus, I imagine he'll say like it should be separable, and you should be able to know which is which. Then again, I think having the IV and ciphertext as sort of one entity together is also not so uncommon. But yeah, if there are strong opinions about it, I would welcome them. I will pause briefly. If there are no opinions, I will continue, of course. But yes.
Hi, Daniel. At this point, I'm starting to wonder: do we need to worry about code point exhaustion in the algorithm registry?
So you're saying we should define like the AAD algorithm as part of the code point?
Not necessarily. No, it's just if we're reserving basically the
Oh,
entire
oh,
half of the
I see.
registry for persistent symmetric key algorithms, how many of them do we expect to eventually need? Have we are we reducing our room for maneuver in the future?
Right. Yeah. So the original idea I had, like the reason why there are so many is because I thought, okay, let's just say that the first bit of the algorithm ID means whether it's symmetric or not, right? Like obviously we could do it a different way. Like I could reserve fewer symmetric key algorithms. So I mean, to be honest, like even having 127 for the asymmetric one still seems like a lot. But yeah, if it's a strong concern, I can. I did intentionally leave the ones above 210 undefined to potentially have the option of saying 255 means like look at the next octet or something like the thing you proposed somewhere. So I don't think it's a huge concern, but then again, yeah, you're definitely right that probably we won't need like 70 algorithm IDs for symmetric key algorithms, right? So yeah, we could reserve fewer if that's preferable.
Yeah, the kind of toy kind of model that I mentioned before. This was off list, so don't worry if anybody hasn't heard about it. But I did mention at one point to Daniel that maybe we could reserve the code points above 127 and do something like a UTF-8 transformation or something along the lines of the packet length encoding or the subpacket length encoding. And if we did it UTF-8 style, the nice thing about it is that it's self-synchronizing, which means that you can't. It helps with non-malleability if we ever need to use any of these extended code points inside a signature trailer or so on. But we can take this elsewhere.
Mm-hmm.
Yeah. Sorry, that's me. Sorry.
Yeah, thanks. I wanted to say out loud the thought that I thought you were going to say in the beginning, which is like, so another option for these, and especially for the IV separability, is we could define the AAD mode as part of the algorithm ID, right? So we could say, you know, 128 means EX, 129 means OCB, or we could have only OCB if we want. The reason I didn't do that is because we already have a registry for AAD algorithms, right? So it seemed natural to use it. Do you offer justification why implementation needs to know ahead of time which unknown PubKey algorithms are symmetric? In most cases, it's not very important, but there are cases where, like, if you're let's say in the extract cert operation, if you're extracting a certificate from a private key, for persistent symmetric keys, you should drop them, right? Like you can't generate a certificate from these private keys. So it's an easy way to just say like these should be ignored. And for that operation, you don't necessarily need to be able to understand the algorithm, right? So yeah, that's kind of the use case, I suppose.
This is Daniel. So thanks for answering the question, but I'm still not sure that I understand it. If an implementation doesn't know anything about these persistent symmetric keys, and it handles this as though it was just doing a pub key extraction, that's going to happen, right? We're going to have implementations that don't know about this, and someone's going to run extract cert or the equivalent on a secret key, and they're going to get out something that doesn't know about this. Are they at risk? Are they is there something wrong with that?
they're not at risk, but the result is unusable, right? So the scenario I was thinking of is more like if you have an implementation that understands persistent symmetric keys in general, but might not understand algorithm ID 130, right? Then you might ask that that implementation to extract a cert from your key ring, let's say, which if it includes both a symmetric and an asymmetric persistent key, then it should only output the asymmetric one. And then it can do the correct thing if it knows that 130 is a symmetric algorithm, even if it doesn't understand that algorithm.
But what does it risk if it does do the extraction?
I mean, there's no huge risk, but it's like if you do a sub extract cert and then you send the result to someone else, it's going to be meaningless to them, right? So it's
just like any other algorithm that they don't understand, right?
Well, yes, but for 130, if you know that it's a symmetric algorithm, you like the generating implementation can know in advance that it's going to be meaningless because it's a symmetric algorithm, so you shouldn't send it to other people, right?
Well, you shouldn't send it to other people because they won't necessarily know what to do with it.
But no, because they will never be able to do anything with it because it's a symmetric algorithm, right?
Sure, but there are lots of things that could be encountered that people don't know that your peer doesn't know what to do with, right? And so what you're doing, what's happening here is it looks like you're setting aside a big chunk of the protocol space for the benefit of not transmitting a relatively small piece of data. And I'm not sure what, like, I'm not hearing that there's any real cost to accidentally transmitting such a thing. And so I'm not sure whether it's worth it. I'm just trying to see the trade-off. Sorry.
I want to jump in. So Justus Winter from Sequoia PGP. I think there's a risk if you have v4 secret key using this thing, because in v4, if you don't understand the public key algorithm, you can't know where the public bits end and the secret bits start. So a naive implementation of v4 might encounter the secret key packet and try the public key extraction, and they may accidentally include the secret key bits. So I think a safe thing to do is to restrict this to v6, where we have an explicit octet count for the public bits. So even if you don't understand the scheme, you can robustly skip the secret key on extraction. Thanks.
Hi, Justus, is that not the same risk that we run for any v4 secret key with an unknown algorithm?
That's the same risk, yes. But we are not running around introducing new algorithms to v4. I guess for a reason.
Okay.
Yeah, I guess we could restrict it to v6. The thing that you do still need is to be able to use it with SCIPD v1 and v3 PKSKs, but I guess that's fine. So yeah, fair enough. I guess being able to use it with v4 is maybe not necessary. So yeah,
we have 12 minutes left in the session, so.
Yes, let's move on. Let's see. Other questions? Yeah, I wanted to talk a little bit about the relation to PQC. Because so what we did, what I did for our implementations is I included this together with the PQC branch, and I would humbly encourage other implementers to do the same if they're thinking of implementing PQC or if they're already implementing PQC. or if you're getting funding to implement PQC, you might want to add this as a line item. Especially because, well, as I said in the very beginning, PQC is gonna add like a performance hit to use cases where you're encrypting something to yourself and storing stuff for archival and so on. And then I started to think maybe we even want to encourage somewhere that when generating new private keys, or even when updating keys, instead of only generating a new PQC key, you might actually want to generate both for the user, right? So like where they have a current v4 single asymmetric key that they use for everything, you might want to generate two v6 keys, one being PQC and one being a persistent symmetric key, right? And then select which one to use depending on whether you're sending it to someone else or sending or encrypting for yourself. Yes, Falco.
I understand this concern for email, for the email use case, but is it really justified to make this a general concern? Because if I use OpenPGP for other purposes, maybe the overhead is not really relevant to me. So this is some kind of making the assumption that this is always relevant.
Sure, it depends on the use case, of course.
Yeah, maybe it can be formulated in a way that makes this clear.
Right.
Okay.
And then, so I also started to think about the replacement key draft, although I think it's maybe not so relevant, especially if we rename it replacement certificate. Or at the very least, you probably don't have to signal to others that you're switching to a symmetric key. But when encrypting with stuff locally, you might want to keep in mind that even if your TSK says that you've switched to a PQC key, that you might actually want to use the symmetric key when that's possible, right? So, yes, Andrew.
Sorry, yeah. Just on that, yeah, I don't think this this applies to the key replacement because there's no reason to put it into the certificate.
Yes.
It would be a local setting in your local software, so I think it's an entirely local decision.
Yeah. So then I started to think a bit about API considerations because when you're encrypting something, especially when you're encrypting something to multiple people and also to yourself, you might want the implementation to handle all of this stuff, right? There is one. So the first point is about the thing that DKG raised, which is about sort of the obvious thing is like in your implementation, you want to be able to encrypt and verify using a TSK in order to be able to use this, right? Like you have to be able to pass a secret key where previously you will be passing a public key. And SOP specifically disallows that currently because it might indicate a mistake if you're passing a secret key instead of a public key, right? But here we might want to make an exception. And we might want to make an exception only if you, for example, pass a flag that says this data is for archival, or it's for both archival and communication, and therefore you can use a symmetric key when you have one available, right? And similarly, you might then want the implementation to select actually which of your keys you want to use. So in the SOP case, what might be convenient is when you pass multiple files, each containing a keyring, to have the implementation sort of select one key from each of those files instead of like the top spec currently says that you have to encrypt with each individual key from each file, if that makes sense. So this is, I'm phrasing it in sub-specific terms, but this I think applies to any high-level API more or less. And then finally, the third point here, we might want to allow generating multiple keys, as I said before, and sort of consider one keyring file as in the way that we're currently passing around TSKs. You might want to pass around a transferable keyring that contains both a PQC key and a persistent symmetric key, and maybe even the fallback key if you have one, the V4 key. That's all. So let me know if you have any thoughts or questions. Yes, Eustace.
This is Winter, Sequoia. About the seed fingerprint thing, I would like to see it be deterministically generated from the secret, I think.
Why do you prefer that?
Well, for one thing, I think it creates a kind of binding between the fingerprint and the key material, which I like. And then there are some people who like to derive key material from in a deterministic way, say from a strong passphrase, and doing that would help their use case.
Yeah, it makes sense. I mean, that's kind of similar to what we had before, right? Like there used to be a key material and then a hash seed, and then the public key would have the hash of the hash seed, right? And I thought it was not necessary because when you're encrypting an AAD key, the key material is already bound to this fingerprint seed. But yeah, if you want to, I mean, you could still store a seed of the fingerprint seed separately if you want. I don't know. I would have to think about if it's possible to drive it from the key material somehow.
And I also want to talk about implementing this, because for us, this will be a major pain to implement, because when we started our implementation, it made sense to be careful about secret key operation, which might operate on a locked key, which we need to unlock somehow, or it may be a remote key, a hardware key that does the unlocking on our behalf. But we haven't done the same for public key operations. But now we might encounter a locked public key. And for our API, this will be a major problem. And I'm wondering how you implemented that in OpenPGP.js and GOpenPGP. What happens if the secret key is locked? Do you just fail, or do you just operate on unlocked keys? What did you do?
Yeah, so in OpenPGP.js and GopenPGP, if you pass, so first of all, it happened to be the case that for our encrypt and verify operations, you were already able to pass a secret key, so that we didn't have to change. But beyond that, yeah, if you pass a key that doesn't have the secret key material, then obviously it would fail. Also, the current draft says that you can't have a public key packet containing these algorithms. But yeah, obviously, if you have a locked private key, the consideration applies, and then we throw an error basically.
Is that the same when you do a decryption? Will it just error out if it's locked, so you have to explicitly unlock it?
Yes.
Okay. Thanks.
I also think the deterministic derivation from the secret key of the public key might be useful. We had already talked about the possibility to use the scheme even for communication between two parties if they share the same key. So it could be that this is just used as a normal communication key, and then it's of course useful to know exactly that a certain private key is bound to a public key, because otherwise there might be at two places the same private key but with a different public key, which would be confusing. So, but I don't know this idea of using it for communication, how others see it. So far I have not seen anyone to jump in on this. I mean, for sure it's not very common to use symmetric keys alone. I mean, as an additional feature, like a group key additionally used to public key encryption, it would be very useful, but that would of course require a lot of changes to the protocol. So I don't think we're discussing about this at least here. So I don't know if there's anyone else interested in this use case. It would also be interesting to know.
So we are just about at time here. So I appreciate that there's discussion on it. We've got 3 drafts that are in play in the working group. And it looks like we've got opinions on all of them and implementations on all of them, which is great. Stephen and I will confer about whether it makes sense to try to have some interim between now and IETF 122 to keep the progress moving. But I'm very pleased to see the active work. Please take a look. We didn't get to the SOP draft discussion, which is fine. I put that there in case we had the time. If you have a chance and you're an implementer or a consumer, please read those slides and read the draft. If folks have specific things that they would like to see covered in a interim, please speak up on the list. So we're at time. Thank you everyone for participating. This has been OpenPGP from IETF 121.
Thank you.
It feels like there's progress.
Yeah, no, the PQC thing is heading towards, I think, if they. Well, no, it's not really there. I mean, the signature part is their fault. The CAM part is their fault. So,